Hello.
Hello.
How's it going?
I'm all right. What's going on, man? How are you?
I'm doing all right. I feel a bit
Oh,
displaced because the camera's over here, but my screen's over here. So
oh,
when I'm
okay.
looking at you, I'm looking over there.
Oh, really? How do I look from that angle?
You look
Terrible.
good. How do I look from this angle?
Don't, don't lie, man. Don't lie. Oh, well, it looks, you look great, but there's
Thank
something
you.
back there. I don't know if that's like an acronym for something, or I don't know. Like, is that like text talk or something? Like, by the way, or whatever.
Uh, Not quite, unless it's
GC.
very, very old text talk.
Maybe, maybe.
I've got
Wait.
here. Sorry?
Go ahead. Go ahead. I'll let you introduce it. All right. Special code here. What
Sure.
is
So GCD stands for the greatest common divisor.
right.
And
And that makes sense. All right. Okay. 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 Go ahead. Go ahead. I'm sorry. I'm sorry.
that's okay. Sometimes it's also known as like the highest common factor. So you might see HCF instead of GCD.
GCD. Right.
Oh, it's so weird having to look between the two screens.
Oh, I'm
Anyway,
sure it'll work out great. It's like you get different camera angles, like, like in those really, really nice productions of movies, sometimes you get one angle, you get the other angle.
there we
So,
go.
so we'll
I love
see.
it.
This may send a new trend. We're
I
looking up.
hope not.
It looks
Let's go back to normal soon.
it looks like you're being interviewed if you're looking off to the how do you call it? To the
Yes,
side. So
I like it.
all right. So what can you tell us about GCD, greatest common divisor?
Well, let's grab our whiteboard up, shall we?
Mhm.
Um, would you know the greatest common divisor or the highest common factor of 4 and 9, shall we say?
Okay. Something the biggest thing that goes into both of them.
Mm-hmm.
One, I imagine.
Yeah, I would
Right.
agree.
Okay.
Excellent, well done.
All right.
Um,
Cool.
what about 10 and 50?
Okay. Well, 10 goes into 50, so 10.
Yeah,
All
excellent.
right. All
I
right.
agree.
So the greatest common divisor at least has to be no greater than the smaller of the two numbers.
Exactly.
Obviously. Okay, cool. All right, all right, all right. I'm on a
Yes.
roll here.
What about if I was to ask you the GCD of 5,817?
Oh man, come on. It's just the third question in the series of all right, all right, all right, whatever. Let's see. Let's see. Oh my God.
Do you know how to quickly work that out?
Oh, you want me to wipe off the top bits?
Sorry?
Just to work this out. I thought you said
Yeah.
wipe that out.
Oh no. No,
Ooh,
work it out.
that's tough, man. That's a tough one. All right, so prime factorization. I don't know. Would that work?
It
No,
could work,
maybe.
but
You can
there's a way that's a little bit easier.
really. So, oh, right. How you have two numbers
Hmm.
and a multiple, like one number equals a multiple of another number plus some remainder or something?
Yeah,
Oh,
exactly.
okay. All right. All right. All right. That's cool because you find out what. Okay. Let's start off. I don't want to say anything that you know.
No, that's good.
All right.
It's
Cool.
called it's no, it's not Euler, it's Euclid. There we go.
Euclid.
Euclid's algorithm.
Euclid's algorithm. Okay. Okay. To find a greatest common divisor, then, right? Yeah. Okay. All right.
Exactly. So,
Okay.
let's do a different
Let's see
color.
this.
Do we have a different color? Oh, we have many.
Yeah. You go
Let's do
to.
blue. So, let's do the bigger number first. That will make sense. 5,817 equals something times 1,428.
All right. I'll just mention the
What's that?
whiteboard is taking a little bit of time to kind of load, at least from my end. I don't know if it's
Oh,
coming immediately. But okay, here we go. Now I see the different color. 5817 is popping
mhm,
up now. Now I don't know if it's just me on a delay or not, but
that's okay.
okay.
Uh,
All right.
we'll go
Yes.
slowly.
Now I see five. So we have 5817. That's going
Hmm.
to be equal to something times the smaller of the two
Hmm.
numbers that we're given. and then some remainder. Yeah, right.
Yeah.
There's going to be some spilling over if it doesn't go into it evenly.
Yes.
Perfect. All right. Okay. How
Uh,
many of those? Three?
well, do you have a calculator on you?
Oh man, I could pop one up for myself here. Hold on. My favorite calculator is Excel.
Oh, fantastic.
I love it, man. I love, let me get it to pop up here. I'm not going to share it with you guys, but I'll do the calculations on the side over here. It's moving along. It's moving along. All right. Yeah. I mean, I would say three of those, man, something like
Three?
that. That's what I'm thinking, but let me check. Okay. So I'm having something equals, what do I want? Uh, 5, right?
Mm-hmm.
58, 17.
Yep.
Yes. Divided by
One.
1428.
Yes.
1428. And we get 4 point blah, 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 4.07.
Ah, so it's
So,
4.
so,
Let's
so it's
change that to,
4 or 3.
whoops.
Oh, that's right. I said 3, but it's
Yes.
4, right? Okay, 4.
There we go. 4. And do you know what the remainder is? Do you know how to figure that out?
I think we just subtract that the 4 bit,
Mm-hmm.
okay, and then divide by whatever or multiply by whatever you divided by.
Yes.
Correct? Okay, so I'm gonna have this equal to let me take this number minus 4. Okay, 4. Uh and that collectively times, sorry, equals this guy times what did we divide by?
41428.
14, 1428. 28. Here we go. And it's 105.
Excellent. So our
105.
remainder
105.
is 105. Excellent. So you got that by this big number minus this multiplication, and that was left over.
You know what? I'm gonna pick up maybe since I'm hosting because it's still showing that first bit here. It's like really, really on a delay. If you
Oh,
want, I'll write since I'm posting it, maybe it'll go a little faster.
sure.
Let me try that. Okay,
Yeah.
so I'm going to see if you see it immediately as it comes up. All right, so I'm gonna take now the 14, am I right?
Mm-hmm.
28, right? And that is gonna equal the 105 times something plus a remainder, correct?
Yes.
All
Excellent.
right, okay. Is that popping up immediately?
It is not. My screen is
Oh,
still
it's
blank.
not. Okay, okay.
Oh
So
no.
is it coming up now? We're on a little bit of a delay with the whiteboard, it looks like.
There we go.
All right, okay. As soon as I get your okay, I'm moving on. So we need to figure out now, do the same thing here, right? So how many of these do I need to multiply to get just under this, right?
Well, let me use the calculator this time.
All right, all right. Switch
So,
roles here.
so we'll do 1428 divided by 105. So that is 13.6. So our
So this is a big
multiplication number
13 right
is
here,
13.
13, right?
Mm-hmm.
And this is 0.6, blah, blah, blah. We're going to have to multiply that, right?
Uh, so that's 1365. So 1428 minus 1365 is 63. So our remainder is going to be 63.
63. Beautiful, beautiful. And of course, these remainders always have to be less than whatever this number was, right?
Of course.
Right.
Yes.
Otherwise, this number would go up by 1. All right, cool. So the next bit, right? I like this stuff. Was
Perfect.
105, right?
Yep.
And then we
Oh,
need
and
to
the 63 has disappeared. That's good.
63. That's cool. Oh, did it? Oh, on the previous line.
There
So
we
that
go.
times something and then plus some remainder here. And we're trying to get this remainder to equal what?
Well, eventually to 0.
Right, 0. That's exactly right. All right, cool. I'm ready to
Excellent.
go. I'm ready to go. This is 1. I'm going to say 1. I'm going to guess 1.
I'm thinking it's 1.
Take
And that would
one of
make
those.
sense because 63 doubled is going to be more than 105.
Yeah, more than that. So just one of those.
Mm-hmm.
And
So
then
let's just do 105 minus 63. And that is 42.
42. Beautiful. So here we have the 63, and we're trying to see how many 40. Oops, we're trying to see how many. Oh, I got excited there. Hold on. Get rid of that. Oh, all right.
Oh, the suspense is killing me.
Sorry. Oh, the pressure's on. My God.
Oh,
God, man. Pressure. 42. There we go. Plus something here. So,
excellent.
shall I?
Sure.
I'm going to say one of these.
I'm going to agree.
All right, cool. So that's going to give us 21, 21, 21, 21. All right, let's see here now. 42. I see a pattern here, or I see something here
Yeah.
specifically. 42 and 21 of these. Beautiful. Plus a big old, what? 2 of these gives us none of those.
There we go. Excellent.
So, all right. Well, so 0 is the greatest common divisor.
Not quite.
Okay. What?
It's the one beforehand. So it's 21.
The 21. That's right. So 21 went into. That's pretty nifty, huh?
Yeah.
Yeah. You
And
go through. I'm sorry. Go ahead.
oh, I was just going to say, we can, use this algorithm to sort of justify, hey, we've just found a really quick way to find the greatest common divisor of these two ridiculously large numbers
Right.
with only like 4 lines of work, 5 lines of work.
That's true, man. That's true. Yeah, absolutely. And they're pretty big too. That's right. That's right. Yeah, that's not bad at all. So this would have nothing to do with prime factorization, would it?
Not necessarily.
Because we're adding those bits right at the end and using those bits in this algorithm. Okay. All right. That's pretty cool. So GCD. No, sorry, let me rewrite that. GCD. Just to finish the thought here. Put some parentheses when we're asking for the greatest common divisor of 5817 and 1428. That's going to equal, in our case, 21.
Love that.
So then we can basically show this, right, as something like some number times some integer times this first number plus some other integer times that second number equals the greatest common divisor.
Exactly.
Right?
Now, I know you've written it on your screen, but on my screen it's too high to be seen. So I'm going to trust that it's on your screen.
It's on my screen. It's on my screen. Okay, does that make sense?
Yeah.
I think, yeah. So, I mean, we can actually find these too, right? What numbers these happen to be. Can we?
Yes.
Should we try?
Can.
Should we try?
I haven't done it in a while, but we can have a go.
Are those somewhere in here?
Possibly.
I'm wondering.
I didn't have a look at this, if I'm honest.
But I mean, that's basically this, right? The greatest common divisor can be found by finding integer values of n and m.
Yes.
Of our, excuse me, in our case, the 5, 8, 1, 7. My God, look at that terrible writing. And the 14, 28.
Excellent.
Wow. Well, it's like we left them on a cliffhanger here. How are we going to get those numbers? Is it like 13 of these and like maybe -1 of these? No.
Perhaps.
Not sure. Wow. All right.
Well, I know that that's called Bezout's identity, but I can't remember how to find it. So we're going to leave that as an exercise for the viewer.
One to this. That's right. That's pretty cool, though. All right. Or we can have the students figure it out and email us and let us know.
Sure. There'll be a prize for the first person.
All right. Well done. That was cool. All right. I'm going to stop this share.
Okay.
And all right. Laura. Well, that was fun.
It was.
And it's pretty cool, man. This is like, well, so Euclid lived way back when. I don't know how many, what was like 4,000 BC or something? Not
Oh,
4,000, 400 maybe.
oh, I mean,
Not
either
that
way,
far
very
back.
impressive.
Very, very impressive. All
Indeed.
right, Laura, I'll talk to you later, okay?
Indeed. See you
All right.
later.
See you in a bit.